This Week in Radio Tech, episode 259, is brought to you by Lavo and the crystal clear virtual radio console. It's the radio console with a multi-touch touchscreen interface. By the Omnia 9, AM, FM, and multi-HD audio processor. Leif Clayson's Omnia 9 delivers exceptional audio integrity and unrivaled flexibility. And by the Axia Fusion AOIP mixing console. Fusion, where design and technology become one. He keeps finding methods and gadgets from outside typical broadcast engineering circles, then figures out how to solve a broadcasting problem with them. It's Alex Hartman, the curious engineer from St. Cloud, Minnesota. Alex joins Chris Tobin and me to discuss how engineering curiosity leads us to better and cheaper connectivity, remote broadcasts, and better radio. Hey, welcome in. It's time for This Week in Radio Tech. I'm Kirk Harnack, your host, and delighted to be here every Thursday, 6 p.m. Eastern Time, 5 Central, and you can figure it out from there. It's the show where we talk about radio technology, audio, metadata, IT. Subjects come up all the time nowadays since we're using so much IT to run radio stations, and RF issues and antennas and things like that. So once in a while we get to talk about, the other end, the stick, the transmitter site. That's a lot of fun too. On this show number 259, we have a guest named Alex Hartman. And Alex is a very interesting engineer. Our subject is going to be about the curious engineer and why it's so important to be curious. So welcome in. I hope you'll stay tuned for the next hour or so. We'll just go as long or as short as it feels good. And along with me, my usual co-host, coming to us from yet another secret location, the best-dressed engineer in radio, it's Chris Tobin. Hey, Chris, welcome in.
Hello, Kirk. Yes, it's a family location. That's all I can say, and it's a nondescript backdrop for that reason.
All right. That's great. And whatever family it is, they got great internet.
It seems to be holding up so far. Yeah, it's I believe it's Optimum cable, so it's so far so good.
Okay. You sound like you might have your doubts.
Well, it's Cablevision.
Okay, well, we'll see if they can handle the bits.
There are people in the audience know exactly what I'm talking about.
Actually, internet is something that we're going to talk about a bit. How speeds have been going up and where it's maybe still tough here and there, and just some amazing things that our guest Alex Hartman has done. So let's go ahead and bring Alex in. Alex coming into us from St. Cloud, Minnesota. Hey, Alex, welcome in.
Hey, Kirk. Thank you.
Glad you're here. Tell me about the shop where you're at.
It's actually my, as Shane Tobin would call it, it's a basement layer of engineering fun. So I've got all my tools and things of mad scientist style behind me to make things that I do. And the curiosity, as you say, the more of can I do it, and let's find out.
Yeah. Well, I'm looking forward to that. So, Alex, your regular day job, I believe you do engineering for a university radio station. Tell us about that.
Yep. I work for St. Cloud State University, particularly the Mass Comm department. We have a single radio station, full power, and an LPFM now, and a cable TV network system. We have 2 signals that leave the university and 2 that stay on campus. So we have a huge television production facility as well.
Cool. And hey, as we get into the show, one of the first things we're going to talk about is your beginnings just before you were a radio engineer, or when you were transitioning from the IT world where you started into radio. You built or helped to build a rather amazing Wi-Fi network. We're going to talk about that. You told me about that earlier, and maybe I've got a fact or two wrong. That's why I want you to tell us about it, and so we can understand how you did this amazing project, and then we'll get into other subjects from there. Plus, folks, you're listening, you're watching. Alex has got some great show and tell for us that is really exciting. Alex is a gadget guy. He likes to get the latest gadget and put it through its paces and make it do what it the designers may not have even thought of. So we'll get to that in a minute. Our show, This Week in Radio Tech, is brought to you in part by the folks at Lavo, L-A-W-O, Lavo.com. And it's a German company. They are makers of beautiful audio consoles, most of them the big kind. The kind that you see at, in television stations and trucks and live performance venues and recording studios. Well, Lavo has a line of consoles for radio stations. They're smaller consoles. It's called their Crystal line. And the latest addition to that is something they introduced right about a year ago, actually at NAB 2014. And Mike Dosh, who's now the head of their virtual radio projects, was a part of that rollout, and he is on the webpage that you just saw there a moment ago, and he's showing how this console works. It's called the Crystal Clear. We've been talking about it here for a number of months on the show, and if this kind of technology interests you, let me encourage you to go to the Lavo website, lawo.com, and look for radio consoles, and then look for Crystal Clear. Now, what's different about the Crystal Clear? Well, like many consoles, it has a rack mount component, and that's a 1RU box, goes in a rack, and this is where all the audio I/O occurs, or at least all the local I/O. It has some microphone inputs. It has some line level balanced stereo inputs and outputs, and then it has some AES inputs and outputs. It also has a Ethernet jack on it, and to this jack you can connect a Ravenna network, including AES 67. Which is now part of the Ravenna spec. So if you want to do AOIP and connect to other AES 67 devices as they become available, you can do that. You can hook it into, let's say, an Axia X node, which does AES 67, or maybe a new Genelec speaker that does AES 67, or other products that are coming out that do AES 67. So now that's the regular part. That's the the rack mount part. The wires go in and out. The DSP engine is in there. The functionality that makes it function as a console is right there. Now, what's the other end? What's the part that the user uses? Well, that's a touch screen. It's a multi-touch touchscreen console. So what it is, it's a multi-touch monitor, and behind it is a CPU running Windows 8, and the console is actually an app, a full-screen app, takes up the whole screen, looks like a console. And it looks like a very sophisticated console with beautiful faders, pre-fader level, for Q, preview, whatever you call it, faders on and off. Then it's got option buttons associated with each fader. So you can, tweak an input if you need to, or change its back feed if you need to, or adjust it in some way. Then it also has your typical knobs, virtual for your monitor volume, your headphone volume. It's got beautiful meters on screen with PPM displays, and it's got all the things that you would want a console to do, but virtualized in a touchscreen. One interesting advantage about this is if you need to move to a different room, you can do that. The touchscreen and the PC that's running it talks to the engine over a network, just a regular Ethernet network. And so if you need to move that console to a different room, if you need to pick that console up, unplug it, take it somewhere else, maybe to the lobby of the radio station, and plug it in there, you can do that and still run your whole radio show from right there. It's a really interesting concept. I feel that more and more people are going to be interested in this and go to this kind of a console. We've already seen other examples of hardware doing this, but now Lavo has this full-time software version called Crystal Clear. And go to lavo.com, L-A-W-O, and check it out. Thanks, Lavo, for being a sponsor of This Week in Radio Tech. There it is again, the Crystal Clear console from Lavo. Okay, so Chris Tobin is with us from an undisclosed location. And tell you what, I didn't get really a chance to say much hello to Chris. Chris, what has been keeping you busy this week? Anything you want to share with us?
This week was a couple of Wi-Fi 5.8 radio installs. That's basically it.
Yeah.
And then there was what's the other thing? Oh, I actually helped somebody put in a video link, an IP video link for a TV, low power TV transmitter. It's pretty cool.
I'll be doing a 5.8 IP radio link next week, and my first one. So maybe I'll need to call you. We'll get the hour meter going on.
Which brand are you using?
It's a Ubiquiti, and in fact, we're going to be talking about that with Alex here in just a minute. Alex knows something about Ubiquiti radios, so we'll see. So, Alex, welcome into being our guest on This Week in Radio Tech. Alex, what made me think about you being a guest is you showed on Facebook one of your many posts about interesting technology. You showed a new Raspberry Pi accessory. And you can show that later on in the show, but that just got me thinking, man, this Alex guy, he is very curious about technology, and he likes to get things and see, okay, what can I do with this and apply it to radio? So let's roll back a bit and start with your IT days. And I alluded to you hooked up a network of a Wi-Fi network that went some distance. Can you tell us about that?
Yep, that was a long time ago in a lifetime far, far away at this point.
Okay.
It's when the internet was kind of a new thing and wireless technology was kind of a new thing for computers in general. I worked for a guy who had this insatiable need back in the mid to late 90s that he would want to go from his house in southern Minnesota to his cabin in northern Minnesota and never lose connectivity in his camper. So as the drive progresses,
this is well before 3G and 4G, right?
Oh, way before. CDMA was still current technology at this point.
Oh my gosh. Okay.
Yeah,
okay.
So dirt slow. But in this time and space, obviously no one had tried to do that, to tower rentals and stuff like that. It just, was almost unheard of. So the concept came that, okay, well, what's out there? What's available? And we found a company called Elvarion and BreezeCom back in the day, very popular with the original 802.11 stuff.
Yeah.
And we went with that. And yeah, it was a little slow, but it was, for traveling along the road, pretty impressive that you get 300K going 55 miles an hour down the road.
Now
and the kids,
you mentioned towers, but earlier today we talked a bit, and you mentioned putting up, relay points on silos.
Towers are actually kind of a weird thing in the middle of Minnesota. We're kind of in the flatlands. Well, he didn't really want to pay for a lot of towers. So his answer at that point was, hey, farmers need internet too. It's kind of this new thing. The co-ops and grain elevators are getting in on it. So let's put these wireless repeaters along the highway that I take for travel, which are back roads where towers usually aren't, that he'd just put them on top of the grain elevators or in the co-ops in the small towns on his way to the cabin. So what they would do is they say, hey, let's put this up here, and hey, Mr. Co-op or Mr. Farmer, we'll give you an internet link for free for using the tower on the silo. And that's how we built an entirely self-sustaining wireless network. And as far as I know, it's still working today. Obviously upgraded, but
upgraded to better speeds.
Oh yeah.
And I would imagine that, do you still have to get internet from one end and ship it to the other? I mean, can't you get internet?
Yes, there is still one entry point, and it comes off of a rooftop in Minneapolis for the highest speed available. I think he's using like 18 gig or something like that right now. But, he gets a gigabit worth of bandwidth out there, and then he schleps it all the way up.
So being involved with a project like that, by the way, how many hop points do you need to go? Was it a couple hundred miles?
It was 216 miles total, and I believe there were, I want to say, 75 points along the way.
Oh, gee. Oh, my goodness.
Yeah.
Wow, that sounds good. 75 potential points of failure?
Yeah, well, the guy had time and money, I guess.
Wow.
It's just one of those things he just wanted to do, and he turned it into a wireless internet provider later on in life.
Okay. Yeah.
So it already had the in there, and so the co-ops and stuff that had been traded before became instant customers.
So let's transition into radio, the subject of our show here. How'd you get into radio from IT?
Completely by accident.
Yeah, most of us.
It happens. Like I said, in a former life, I grew up in the IT world. Then the dot-com bubble happened, and I'm sure Chris Tobin can attest to, when that happens, you do what everybody else does, find new work. So I went to school to re-educate myself, went to university. And that's where KVSC came in. And I was down at the radio station one night with a friend of mine who was a host on the show, on the radio station. And I had spilled coffee in my laptop the night before. And it's like, do you guys have tools? Can I take my laptop apart and try and fix it? And the engineer was there, and he saw me doing this, and he says, hey, do you know how to solder? And I said, yeah, I'm sure I do. He says, you're hired. And never quite left. So that's my accident into radio entirely.
Wow. And what were the colors that you gave for that?
KVSC.
Okay. And is that where you're at now?
Yeah. Well,
Oh, okay.
at home, but yes, that's the radio station.
Yeah. Okay. That's okay. Then that's the station at St. Cloud University.
Yep.
Cool.
And
So,
16,000 watts that could.
yeah. Tell you what, maybe now's a good time to do the show and tell, and about a few things that have become very interesting to you lately, and then we'll end up our hour here talking a bit about philosophy and why it if you're an engineer, man, you got to be curious or die.
Yeah,
you
absolutely
got to be curious.
You got to keep current with something.
Yeah.
And that's where the transition came from. When I started college in 2001, I was fresh off of dealing with Cisco Beta Lab equipment, high-end IP stuff, building wireless networks across the state. And then you go into radio, and it's like walking into the Stone Ages, comparably. So it's like, how do I take, this IP device here and marry it into the radio world where it's never been done before, and where it would be perfectly usable. And, coming of age has to happen as well, but it certainly did.
So as long as we're showing and telling, you just held something up. Tell us what that little box is.
It's an air gateway from Ubiquiti. I'm sure Mr. Tobin has seen one of these before. They're cute, they're cheap, they're easy.
Oh, yeah.
More and more transmitter sites have more and more IP-based equipment in it. But the problem is it's not always convenient for you to walk over to the desk where your computer may be, or the workstation. Well, you need to change something on an audio processor, or your delay on the processor, or something like that. Or you're at a client site and they won't give you a pair of keys, or you locked yourself out of the site for some reason. Well, you can do it from the car if you just put one of these little boxes inside your rack and open up your laptop inside your car, and you don't even have to set foot in the building to find out what's going on. Best $20 I've found so far for a transmitter site.
So it sounds like it's a Wi-Fi hotspot.
It's a Wi-Fi access point. You just plug it into your switch. You just plug it into your switch that you already have out there, and it just advertises 2.4 gigahertz that any laptop or phone can see. Obviously create a password and keep everything secure. But one of these little boxes is $20. Really hard to not justify that.
Okay. And what's the? I guess the obvious answer my own question. What's the benefit of this over maybe a more typical? I got a couple of hotspots, gateways in the house here, Wi-Fi points, and they're about $80 a piece. One of them's a Ubiquiti. It's kind of a little more high end one, and one of them's an Ingenious. The benefit of this one is it's $20.
Pretty much, they're disposable, as far as I'm concerned. So if and when they fail, I'm not out $100, and you're going back to the station management saying I blew it up again 2 years later. $20 is a lot easier for them to swallow. Also, some of the bigger ones, for instance, you go find a Netgear. I mean, how many times have you seen a Netgear and you're like, where do I put this thing? Because it's not rack unit size. It's not even half a rack unit size. How do you mount it? Yeah. These things just plug in to the power brick, and you just leave it dangle on the power brick. Or zip tie it to the back of the rack and on the riser. And you can even use the rack itself as shielding to limit the distance the Wi-Fi can actually go, so you security through obscurity in that same point. Yeah. And
I take it does all the usual, security things.
Does all the security stuff and does all the things you would know and love for a Wi-Fi hotspot. I mean, yes, I would call it is in the consumer realm, I would guess, no more than a Netgear would be. But, Netgears, how often find a regular access point this day and age? You really can't find them. They're all tied to a router or some other appliance.
Or they're $150 because they're part of
or they're $150 or more because they do something very special, VPN or something. But they're just finding an access point this day and age is extremely difficult when you don't need another router. So that was my answer for it.
Wow, cool. And so I just found them on Amazon, Ubiquiti Networks, Air Gateway, Indoor Access Point, $18. It powers over PoE. Does it come or does it
does not come with the power brick. No, you have to add the power brick for another $12 or whatever.
Or if you have a PoE switch, then you're set.
Or if you have a PoE switch. This one actually in particular.
Tell me something about PoE here. Most PoE is 48 volts, but the stuff from Ubiquiti and some other companies is 24 volts. Why is it weird?
I'm not quite sure why they designed it for 24 volt. I think it had to do with noise rejection, and they just kind of bucked the system, and that's what they knew. They were Motorola guys, which was funny because they use 48 volts in Motorola.
Yeah.
But the ubiquity stuff, for some odd reason, I think it had to do with the keeping things cool and the voltage converters and stuff like that inside.
Yeah. So
And the regulators. But this one in particular, you can see here, there's just a little RJ45 sticking out of the top of it,
yeah.
and it just plugs right into the power brick, and it just looks like another power brick. And on the end of it, it's got PoE and LAN pass-through. That's all it is.
Okay, so Ubiquity makes a power brick for $10. I see it right here.
Yep. So for $30 total.
Yeah.
Again, like I said, try finding just an access point. They're harder and harder to find today.
Interesting. Cool. Okay, so that's one show and tell item. The Air Gateway from Ubiquity Networks.
Yep.
Pop a little Wi-Fi hotspot anywhere your network is that you need some Wi-Fi.
Right. Next on
by
that
the-
list, sticking with the same
By
theme.
the way,
for
I have a
transmit.
question for you about multiple Wi-Fi hotspots in a building or a house. A lot of times, even a commercial Wi-Fi hotspot won't quite cover your radio station,
Right.
and you need a little fill-in here and there. Is it okay to name other access points the exact same name and give them the exact same password for the encryption? And will that generally work for walking around with your phone or your laptop?
Not necessarily, because they're not running in a repeater mode, because they have a specific MAC address for the wireless
Oh.
radio. So you still
Okay.
have to disassociate and reassociate. The best method
Yeah.
of that is the Air Gateway actually does do something, and all Ubiquity products for that matter do something a little more unique, is they actually have a repeater mode built in.
Okay.
So they'll listen to a master node. Say you've got a radio on the far end of the station, for instance, and you can't quite get down the hall to the sales gal at the end. Well, you put one of these just randomly somewhere in a cube farm without any wires. It listens for that other signal and repeats it.
Oh, okay.
So
okay.
it's a range extender in its own right too.
Gotcha.
So just using those as range extenders works perfect.
it has a range extender mode. Cool. Okay. All right.
And
Let's move on.
again, yep. The next thing, sticking with transmitter sites and Ubiquity in general, big thing now is site security. Really a big deal now. Copper prices are up. Everybody's after that money, or the environmentalists are crazy about hitting birds. Kind of a big deal around here since Minnesota is very flat. So we have to maintain that kind of security and common sense with the EPA to keep everybody happy. But you want to keep an eye on it from afar.
Yeah.
Cameras. Everybody wants cameras.
Yeah.
And camera systems. Ubiquity does make outdoor cameras.
Okay.
Network in. It's a network cam.
Yeah.
Stationary. Their newer models do have infrared lighting, so they can do 0 lux. This one in particular does 1 lux. But I mean, at a transmitter site, I have a giant sodium light already anyway. So, but from afar, this camera again, $100. Put it on the door of the transmitter site, and it sends you an email anytime you fill up a frame of video, for instance, or it'll start recording on movement and send you the video. Or it's just an RTP video stream. Just stream it to your TV and leave it on full time, however you want to deal with it. But it's a $100 answer to possibly save you millions.
Yeah. Yeah. And of course, that is an IP camera. There's a lot of cheap cameras on the market that are not IP. They're wired. They're composite.
Right.
And I've got several of those around
Siamese
the house. here
cables everywhere.
Yeah, Siamese cables, exactly. So a lot of us engineers, and I'm getting ready to begin solving this, but a lot of us engineers have a transmitter site with no internet access at it, and we're going to get a set of IP radios and shoot from the radio station, from the studio to the transmitter site. Maybe
Right.
we're sending coded audio or maybe live wire across that. And we'd also like to have access, start putting some accessories out there that are IP,
Right.
like a camera. What advice can you start to tell us about, getting that IP link to the transmitter site?
Well, first and foremost is, what do you have there already? A good majority of rural, again, Minnesota being the basis, and Chris Tobin being some undisclosed location somewhere near New York, I'm sure, these don't really work very well in New York. They all have power landlines of some kind, T1 or whatever. But out here in the sticks, we use microwave. traditional 950 links or 5 gig links or whatever. You start thinking about that, and it's like, okay, I have a path already. It's already scheduled. It's already laid out. It's licensed. I know it works. What can I do to make it more robust? Well,
No,
there's
you're
obviously
speaking of, when you say you have a path already, you're probably speaking of the 950 megahertz path.
right 950 or a 7 gig microwave link or something like that.
Okay.
That's
okay.
just purpose specific. 950 only carries audio. A 7 gig sometimes only carries video. Things like that. Where they are just what they are. You can't ride the IP alongside of them. So how do you multiplex that? And here's the curiosity part. It was, how do I do it? Someone's done it. And after a little bit of research, obviously the Mosley LAN link is a contender out there. It exists. It's already there. They have everything built into it for you. But it's a pretty penny. Being a public radio guy, we don't have that kind of money to throw around. Quite honestly, we have more money to throw at curiosity than we do at commercial products to solve certain problems.
Yeah. Okay.
So my answer was, we have a 950 link. Okay, well, I've got a Starlink on it right now. The LAN link upgrade was twice as much as the Starlink. Well, hold on. Let's see what anybody else is doing. So I called my friends at Ubiquity and I said, you guys have 900 megahertz radios. Can I multiplex it with a 950? And they said, absolutely. We've done it before. So I spent a lot more money on Microwave Filter Company to make a combiner. And then you get this guy.
Okay.
This is a 900 megahertz Ubiquity radio that has an external antenna jack.
Now, by the way, does that have an internal antenna built into it, or only the external jack?
It has a MIMO antenna. It's a 2x2, so it's got horizontal and vertical antennas built into it. But you can go through their software and turn that internal one off and turn on the external, which is a single polarity antenna, which is perfect because I wanted to multiplex it in with my 950 STL, which is a single polarity as it is.
Okay.
So by doing so, I now have the ability of 36 megabit bidirectional to and from my transmitter site over my traditional 950 link. And that was for $2,000 total cost, and that was mostly Microwave Filter Company, compared to a LAN link that provides 2 megabit at the most, used to, and I think they've gone up since then. But in that same vein, it's, a LAN link is several orders of magnitude more expensive and not out of the reach of pubcasters mostly.
So this lets you use your existing 950 megahertz antennas, which are good enough at 900 megahertz as well. Is that right?
A majority of them. There's only one antenna maker out there that makes a feed horn that is tight to the STL band and not wide enough, but they sell a feed horn kit that you can change it out and it'll be wide enough for the ISM band. But mine in particular are Mark dishes, 4.5 feet tall, that had perfect feed horns on it for it. So just plugged it in and it just lit up.
Now, the box from Microwave Filter Company, that was, you had to get one at each end, and that was to combine your 950 megahertz STL transmitter along with this 900 megahertz ISM band data radio, right? Combine those together. Now you're going into one coax up the studio tower. Yep.
And right into the antenna. And yeah, you have to have one on either end because, well, Wi-Fi is bidirectional and you have a transmit on one side, so you want to keep the radios away from each other.
Yeah.
So you have to pay to play in the combiner arena, but otherwise, if you can get away with it, the other side of it too is put up another 900 antenna right below.
Well, that's what I was going to ask you. Yeah, so you could, instead of the Microwave Filter Company combiners, you could just put up separate another
antennas.
set of antennas.
Correct.
If your tower will hold it, you got the coax cost and grounding kits and installation and all that cost too. Okay.
Right. And if you're going to put up the other antenna, the idea behind the 900 was that the antenna wasn't a purchase item. You didn't have to think about the antenna because it was already there. If you're going to put up a separate antenna, go big or go home. Quite honestly, the 900 stuff is spectrum limited and it's going to get tighter. And with the TV band repack, that's the STL band is kind of in the sharp eyes of all the cell carriers now.
Yeah.
So the idea was put a 5.8 gig link up. ISM out here in Minnesota, we have cows and corn. We don't really have cityscape to deal with. In New York City, I would never recommend something like this, but in rural Minnesota, absolutely. 5.8 unlicensed links going 16, 17. I've got one that goes 31 miles.
Wow.
That gives me 100 megabit throughput on bidirectional.
Okay, let me back up a couple of questions. Would you mind telling us the brand of STL antenna that you need to watch out for, that you may need a different feed horn for if you want it to be wider?
It's the Catherine Scala that's specific. I can't remember what the exact feed horn number is, but if you go to their website, they show you exactly what I'm talking about, because people have called them all the time saying, "Hey, how do I do this?" And they usually, first thing they ask is, "Well, you need a new feed horn, don't you?" So
Got you. Okay.
Yep.
All right.
So
Yeah.
like I said, if you're going to go to separate antennas, it's probably better to go a higher bandwidth than the 900 megahertz. But the 900 megahertz adds a layer of redundancy as well. So if you've got IP plus audio, you got your traditional audio link out there plus the IP, which you can create as a secondary if you don't trust it. For instance, I trust it. It doesn't mean you do. So you could ride both IP and traditional audio out there over your existing system, and work with it once it gets out to the transmitter site, whether you use a silent sense on one side or the other, or if you just want sheer data and no audio going over the IP. Or in my instance, I mothballed my entire Starlink system because this was just so reliable.
You mentioned the 31-mile hop. Tell me about the antenna size and the frequency, and what kind of radios are you using for this IP link?
Again, ubiquity, and the antenna size is huge.
Oh, okay.
It's an entire product that you can buy from various Ubiquity dealers, but it's a 3 foot tall. They call it a rocket dish, and it's a 3 foot tall 5.8 gig dish with RF armor, so it's got the drum head on it, and height. If you're in flatlands, you need height, which we're flat. So one side of that antenna is up 260 feet, and the other side is up almost 1,000 feet. So
wow.
It's got a big hill in the middle, so we had to get high enough over it. But I can do 100 megabit wire speed over that link 31 miles away.
When you go 1,000 feet up, and I was calculating some tower heights for my antennas for 5.8 gig links in Mississippi. Also very, very flat, and no hills in the way. I mean, there are large swaths of land where the land is plus or minus 1 inch. For miles. So they have rice paddies there. They got to be flat.
Right.
So
Right.
how do you? The usual limit for Ethernet is 328 feet or 100 meters.
Right.
How do you go 1,000 feet with an Ethernet type connection?
Trickery.
Okay.
Media conversion, really. Tap off the power, off the tower lights, and create a lineup that's powered, and fiber. Fiber down the tower. Best and easiest way to deal with it at that height. Same way with AM towers, for instance. Cross an insulator on an AM tower.
With fiber.
You would just do it with fiber, and tap the tower lights on the other side.
Gotcha. Okay, so you say tap the power lights. That's where you get your 110 volts to then run the media converter that converts from fiber to Ethernet to fiber. Okay.
Correct.
Wow.
Yeah.
Hey,
so you have to use that.
I think Chris Tobin is back, and I wanted to check something that you said, and I believe you, Alex, with Chris. Chris, if you wanted to do a 5.8 gig unlicensed point-to-point microwave hop in New York City, is that doable?
Yes, I did it for 9 years from Midtown Manhattan out to New Jersey. It was a 9.8 mile link, and it worked very well actually for 9 years. It was
Wow.
what was it, 50 megabits we had, and what I did was, and this is not a trick. This is what you link budget wise when you're designing things in the RF world. Always oversize it if you can. So instead of using the what they said was, I had the company that sold us the equipment do the link budget to see what they came up with, and they were recommending these little 1 foot flat panel, as the industry calls them, pizza box antennas. And I looked at it, I was like, that's interesting. I said the only problem is going across a body of water, the Hudson River, and I said rain fade and moisture and everything else. So we went with 2 foot dishes on both sides.
Yeah.
My link budget went through the roof, and for 9 years, the RSSI never wavered more than a half a millivolt on the display. And during the worst thunder showers you can imagine, storm cells, just torrential rain, we never lost the link at all. And thank goodness we did the 5.8, because during the blackout here in New York City, that link also had an off-premises extension for my phone system to the transmitter site, a ring down line, and a few other things. So we stayed up and running, and I actually was able to get an ISDN line across that back to us at the newsroom. So we had ISDN
Nice.
from the New Jersey side, and everybody was like, "How did?" And then it was just one of those capital projects that I put together. And I said, for disaster recovery, we should consider getting off the grid, so to speak. We should be in control of our destiny. And it took a little doing and a lot of arguing with the financial folks, but a year and a half later, it paid off in spades.
Wow.
Yeah, in New
Wow.
York City,
Yeah.
if you can justify the cost, it's worth every penny.
Yeah,
Around
so 2-foot
here,
dishes were not that expensive, but it was well
Right.
worth the trouble of it,
Right.
designing it that way. And I just wanted to Alex, the 900 megahertz. 900 megahertz, if you can take advantage of it, use what you can for bandwidth. But the nice thing is you're protected more so from rain fade and other conditions that propagation at the higher frequencies. So 900 megahertz not
Absolutely.
only gives you redundancy, gives you probably more reliability. And if you have the right antenna, if you're using the Annex or Mark antennas of old, those are great front to back ratios.
Yep.
Beam width is tight. You should have no problems making that work. If you use the Scala, the PR450s, those were designed to really be spot on frequency, and that was it. If you can do the bandwidth change on the feed horn, those two, when properly set up, can work really nice.
Huh.
Yep. Yeah, that's been the findings from a lot of people.
Talk to
I've
me
done
about
some good stuff with them.
I think this 5.8 gig equipment is pretty popular. That's one of the most popular things, I guess, that Ubiquiti has. The physical sizes work out nicely. There's unlicensed spectrum there, so you can just put something up. Tell me about if I have some dishes, maybe that are either a foot or 2-foot dishes, probably better. What you said, Chris, and I want to shoot across maybe an urban area to get IP from one place to another. I know that Ubiquiti radios, and I'm sure others do too, have a system whereby you can look at, even over time, you can look at the congestion of all the channels that you have available to you, and you can choose the least congested areas. And then while you're in operation, you can even tell the radios, some more than others, you can say, hey, always go find the least congested channel to operate on if you're having problems. And so these radios can automatically do all that. So my question is this. Have you ever run into situations where it's just not doable because there's so much 5.8 gig already out there? So that happened yet?
A couple times, actually. Believe it or not, our biggest challenge in Minnesota is cows and corn when it comes to RF. Back to Chris's thing there about the 900 megahertz stuff, the other thing that we have in Minnesota is Norway pines. So while we have really nice tight links, pine trees get in the way, while the pine needles are just about perfect to attenuate every 950 meg link out there. So water absorbs everything. Yeah, it's ridiculous. It just causes weird problems. Had to chop off some lady's tree once. I won't go into detail on that one, but it was fun. But yes, I have run into that. Sheer number of overload, quite honestly. Festivals. I do stuff with the Oshkosh Air Show. And the sheer number of people out there with iPhones on just looking for Wi-Fi in general just raises the noise floor beyond usable for a lot of things.
Oh.
And that's where the problem starts coming in as well. How do you get around that and how do you mitigate that? Well, the one nice thing, a lot of the products now out there in the commercial realm for Wi-Fi have built-in spectrum analyzers. Like you said, they'll hunt and find the lowest one and go there. But you could also be more proactive about it and know it yourself instead of trusting the equipment, saying here's where it is, what it does. Is the Ubiquiti in particular has the equipment inside of it where you can open up. It's an intrusive process, but you can open up a spectrum analyzer and you can see where your problems are. And if you see a 3 megahertz chunk on the 900 megahertz region or a 5 megahertz chunk in the 5.8 gigahertz region, and all you need is that 3 or 4 megabit worth of bandwidth to get through, say for a remote broadcast, for instance, you can actually narrow the radio down that tight and squeeze it into that hole.
Yeah. I saw that with the setup on these radios. Hey, guys, we're talking about curiosity and engineering and how we discover technologies, and Alex is very well informed on these things. Actually, so is Chris Tobin, and I'm just a beginner at setting up links that are higher than 950 megahertz. So I'll be doing that next week. I plan to, if it works, I plan to take pictures and do a little report on it for you, maybe a little video. You're watching This Week in Radio Tech, our weekly podcast where we talk about lots of things that have to do with radio and audio technology. I'm Kirk Harnack, along with Chris Tobin and our guest, Alex Hartman from St. Cloud University. So our show is brought to you in part by the folks at Omnia. And I talked to Alex about this before the show, and he agreed to help me out a little bit with this advertisement for the Omnia 9, the Omnia 9 audio processor. Now, in the last few weeks, we've been talking about the Omnia 7 processor. Well, the Omnia 9, that's the predecessor. That's still the big dog in the Leif Clayson designed audio processors. There it is, the Omnia 9. It is a big, beautiful box that does a lot of things. I mean, the list of features is as long as your arm, including front panel touchscreen. You can do all the controls from the touchscreen if you want to. You can use a great interface called NF Remote and get into it. So just lots of cool features. Alex, I'm going to work on a little problem here with my video. If you could understand, you have a few Omnia 9s. Tell folks about your experience with Omnia 9.
Well, we had a rash of people replacing transmitters in central Minnesota, and I'm the local contract guy public radio guy, where he just doesn't work for Clear Channel or Town Square, so we can let him in. So the answer was, hey, come over here. We bought a new transmitter. Hey, what do you recommend for a new audio processor? Should we keep using the CRLs or the Unity 2000 we've had here for 30 years, which was actually very commonplace out here? And I said, I've got this Omnia 9 on the college radio station, and I love it. You should probably just pick one of these up because you're going HD as well. So you're going to need processing for HD, and you're going to need processing for streaming. And hey, guess what? This box does it all. And I worked with Leif on a couple of things on how to get it tweaked just right, and I've installed 13 of them in the past year, and not a single one sounds the same, which is very impressive for an audio processor that has the same name badge across the board.
So thinking about, and I'm sorry, I don't have video at the moment, thinking about the features that are in your Omnia 9, all the ability to process HDs and do streaming, do emergency replacement audio if you need to, and then all the ways you can set it up. What are some of the features that are built in the Omnia 9 that you tend to use and like?
Well, the metering is huge for me because I can actually see what is happening in real time. And the jocks can understand it just as much. I bring it up in front of them saying, don't do this. You're pushing it too high. And they'll get it. It's like, hey, look, I can actually, it's a visual representation of what they're doing wrong. On the other side of it, too, we have, undo. One of my clients is a hard rock station, which they purposefully molest every song that comes in and pushes it through the roof and purposefully clips everything. Well, undo definitely helped in that arena and made the owner realize, I probably should redo my library. But the benefits of that unit have definitely paid off in spades for a lot of stations around here, especially with the streaming. I'm lucky in the fact that I can host my own internet web streams at the university because we have more bandwidth than anybody else, to the tune of almost 2 gigabits on campus. But I use the Omnia 9 to generate those streams to my IceCast server for the university. But there's one of my customers has uses a stream host system where they only have a 32K AAC stream. Well, I just plugged in all the information into the Omnia 9 for the streaming and set a preset for processing that looked close to his HD stream and sounded really good at 32K, and said, here you go. Now you don't need that extra piece of processor sitting in their back room just dealing with the streaming. This one box is doing it all for you, which a lot of people around here are like, well, that's a lot of eggs. And I'm like, well, power goes out anywhere, you're off the air anyway. So the justification was pretty easy around here.
Yeah. Wow. One of the things that have been talked about lately is the stereo embedder technology, where you actually get a dB of extra free loudness because of the way Leif Clayson in the Omnia 9 designed the stereo embedding to be. Have you found that to be useful for you?
Oh, absolutely. Believe it or not, it's very noticeable. A couple of the commercial clusters in here in town don't have the freedom of saying locally, hey, we want to buy this audio processor. It has to come down from corporate. So they're stuck with antiquated. I call it antiquated. Like an Omnia 6 EX or an Orban 8200 is on the air still here in the market. There's an Orban 8000 still on the air in the market here, with a couple of CRLs. They would love to be able to say, I can't. They go back to corporate engineering and senior vice president saying we can't be competitive because this entire town just bought Omnia 9s. And so they're slowly coming around to saying, hey, this is what's happening.
Cool. Well, the Omnia 9 available from any Omnia dealer, and the folks at Telos and Omnia would be we'd be delighted to have you buy one, look at it, play with it, listen to it. Leif Clayson is the developer on this product. Him and other members of the team as well. You can get a variety of different options for it. It's got dual power supplies, all kinds of input and output options for you, and it can do multiple processing channels at the same time. Best way to check it out is to go to the website at telosalliance.com and then click on Omnia and look for the Omnia 9 audio processor. And like Alex, you'll be very pleased with it. And I'm delighted to say that I know Alex well enough to know that he would not shill for anybody unless he believed in it. So I appreciate Alex's kind words about that. Hey, Chris Tobin, you and Alex are going to take over for a second and chat about Raspberry Pi coolness and the things that Alex does with that.
Okay. Yeah, no problem. Actually, that would be pretty cool.
I'm sure everybody out there has always wondered, everybody's seen, what's a Raspberry Pi? It's very tasty if grandma makes it, but what's the computer version? I have a small army of these things running around all of my stations. Quite literally a small army. They're all wired. There's no wireless in these ones, but you can add wireless through USB. However, I call them little problem solvers, things that you just can't find a commercial product for that just fits the bill just right. For instance, I have one here that I made, and again, being on the public radio budget of $0 usually, we needed a codec to work on campus for specific events. Think commencement or theater and arts programming and stuff like that. My HD4 signal for the college station is designated just for programming from the university, for instance. So instead of spending a lot of money and training people, which you would have to get some pretty decent training on certain pieces of equipment in case of emergencies if it doesn't work right, what have yous. My answer was, why not a Raspberry Pi running a piece of software called GStreamer, and we put a sound card to it. So that is a Wolfson audio DAC card on a Raspberry Pi. So it has audio in, audio out, and audio out for monitoring as well if you really wanted to. It's configured that way. I have one of these sitting in the radio station, actually out at the transmitter site, running over my IP link, and it's plugged into my HD4 as the primary audio source. The backup audio source is actually an internet stream from the university that's always on playing something. But for live events, you want it to break in, so with an audio-controlled relay, it switches from its backup source, which is usually what's playing, to the primary source, which is what the live event is. So, with that, I hand out a Raspberry Pi, pre-configured to call home, and they plug it in. Plug it into anywhere on the university, plug your audio input, I give them a cord, and
Well, Chris, is it you and me?
I guess it's just you and I. That's it.
Okay.
I guess Alex just lost his connection.
on the public internet.
I'm sure we'll get Alex back in a second. He's got some pretty good internet there. So, and I'm sorry, I had to be offline.
Just how it's routed.
I had to be offline. He showed me that that Raspberry Pi codec earlier today, and I thought no, on the one hand, it's amazing. On the other hand, I'm really not surprised that
I wouldn't be surprised either.
Yeah, you can dedicate a Raspberry Pi to to doing basic codec. It's not so different from. I mean, I know that the people at Barracks have a lot of development behind their product, but in terms of its simplicity and what it can do, it's not so different from a Barracks codec. Alex, are you back with us?
Yeah, I mean,
Yep, I'm here.
oh, Alex,
Okay.
back.
Yeah, Barracks it would be a good comparison. Other than the fact that it's not running MP3, I have it running Opus. But yeah, for a closed LAN situation where, hey, I want to put commencement on the air and it's a regular tech from the college versus, a broadcaster who knows the technology, like if I was to put a zip stream or something in there and have to use something more professional, they understand. Here's 3 connectors. They're even numbered 1, 2, 3. And I show them basically IKEA instructions with pictures here.
Yeah.
Here's how you plug it in and turn it on. So with that solved a big problem for us, was how do we get it programmed hands off? I don't want my program director spending time, or my promotions people or anybody else running around, or me for that matter. We've got 9 different things that are happening on campus at one given point. That's just one person running around plugging in equipment. Instead, I can just hand these things out like candy, and I'm not worried about it if they lose a $35 box.
Wow. Yeah, that's pretty interesting. Hey, show Chris this other Raspberry Pi thing that you have, and tell us about that. It's it might have some real. It might also have some real radio station application.
It does, and I'll even plug it in for you to show you. I found this on the internet. I'm a sponge for technology in random corners of the internet, and this is a 1 rack unit tall LCD in a 1 rack unit panel, with a Pi already built in. It is 1024 by 100 resolution, so it's not the greatest resolution in the world, but it's functional. Now, what could you use? See, there you go.
Oh, it's booting up. Oh my gosh.
And there's a Raspberry Pi.
I just read about that the
one
other
rack
day.
unit.
I was just reading on that.
I found it on the internet, and I said, I have to try one of these because I could think of 90 different things I can use it for in my facility alone. So there you go, Raspberry Pi login.
So it's sitting at a login. Now, what development will you do, and what do you think will be quickly available in the open source community or commercially?
Well, it's just a setting, really. You have to know your Linux, you have to know your Python, and all these other fun things when you deal with Raspberry Pi. So you have to be more well-versed and follow YouTube tutorials and things like that. So you just have to start with a basic idea. And again, there's that curiosity factor. What can I do with it? Well, I look around my facility, and our biggest problem right now is information overload, really, for the jock. I have 9 monitors in my control room because that's how many things my jock needs to see at any given point. What can I put on this little thing above the CD player that he can see at a moment's notice, at a glance, that I can take away one of those 20-inch monitors from? So that was the idea behind this. So metering, for instance, you could put get a LiveWire driver, for instance, and put it on the Raspberry Pi and display metering, like we were talking about this morning. Or put it in the TOC and have a bunch of channels going into it from various sources, and you can have a rack metering system. Simple other things, clocks, internet requests. Just have it scroll a script that checks your email for you and say, here, Billy wants to hear this song, and it puts it up there. Or EAS alerts. EAS is available over IP if you know how to manipulate the data. I'm sure Steve Johnson you had on the other day.
Yeah.
You could use that same system, which I'm using actually as well, and I'm going to do exactly that. My EAS alerts are going to show up on the screen, and those are things that I can take away from one of those 9 screens that I already have in my control room. So the implications are almost endless because the Raspberry Pi is already in there. The display is integrated. It's even got a little jog shuttle wheel on it, so if you want to do multiple pages and menus, you can do that. It's just a computer. All you have to do is tell it what to do.
What's the name of that box?
It came from a company called Earth LCD. They're an industrial LCD manufacturer.
Ah, okay.
And they specialize
sell it
specifically in those.
They sell it with the Pi already there?
The Pi, the screen itself and everything, all as you see here, was ordered as one unit, and it was $250. which is
Huh.
I thought pretty reasonable. If you think about what you're actually paying for, is he sells the screen bare. The bare screen is $89. So
Yeah.
you add in a Raspberry Pi 2 with his HDMI interface system with the jog shuttle wheel and the metalwork. Yeah, he's probably making $10 on the thing. So not a whole lot of money for him in there, and it's open source hardware. If you want to redesign it, I'm a big proponent for the open source movement myself. You want to finish the casing, for instance, because it doesn't have a finished case. It has screw holes like you're supposed to. Here's where a case would go, but it doesn't come with it. So he gives you the Eagle files, and you can take it to your metalwork guy and make your own case for it. You don't want the jog shuttle wheel, delete it. Things like that. It's actually very cool.
Huh. Cool. Yeah, I'm at Earth LCD has their own store. Apparently, what you have there is not being sold on Amazon just yet, but somebody.
No, it's called the Pi Rack.
Pi Rack. Okay.
With a Q. PIRAQ.
Of course, with a Q.
With the Q. At least it doesn't have an I at the beginning.
The Pi Rack. Yeah. Okay. Cool. All right.
So there's many implications in any radio station, whether it be at the TOC level, at the jock level, or even operations level in the management's office. You could see phone lines, things like that. Interfacing, like I said, it's just software. Transmitter sites, at a glance transmitter readings. If you can get the SNMP data spit out of your transmitter and have this read it, it can show you transmitter readings, and here's how you log them. Very easy for the jock to deal with. These are things I'm just coming up with right now. So
yeah, I hear you.
There's a lot of implication there with a lot of this hardware that's out there that, you just look at it and everybody's like, well, I don't even know what I'd do with it. Well, wow. Be creative. Imagine it. Like I said, if Disney wouldn't sue me, I'd have a different title.
Hey, Chris and Alex, we're going to be running out of time pretty shortly here. I want to come back to both of you for, basically your not so much a tip of the week, but the subject here is curiosity, and I hope that people listening to, certainly I have gotten this from, and I always get this from Chris, because he talks about wild, cool uses of stuff that I certainly wouldn't have thought of, but it makes total sense once Chris explains. I use this TV STL to do a radio show, and it works great because this, that, and the other. And the same thing with you, Alex. You tend to take things from other disciplines, other industries, and apply them to broadcasting in ways that make sense and are meaningful. And Chris does this typically in the largest urban environment in the U.S., and you do it out there in the wilds of Minnesota, where you've got cows and pastures and pine trees. So it's kind of interesting. I'd like to get a summary from each of you when we come back from our last commercial about the value of having this kind of curiosity and why it's important, not only for you, but why it's important that all engineers who want to move ahead and provide great service for their client, whether it's their employer or contract client, why this is important to have this kind of curiosity and how it's helped you. Our show This Week in Radio Tech is brought to you in part by my friends at Axia and the Axia Fusion AOIP audio console. The Fusion console is basically the culmination of having built Element consoles now for 7 or 8 years, getting feedback from customers and realizing, there's some things that customers want that we can now do. And the Fusion console is the result of that. Yes, it's an AOIP console. Of course, it's perfectly compatible with the Element and the smaller consoles, the IQ and the Radius console, and also the rack and the desk consoles from Axia. The Fusion, though, basically it's got all these features that are built in and in a design beautiful way. So every channel on the Fusion console has an OLED display, and this OLED display shows you really clearly the channel number, the source that's going on, and it shows you a confidence meter of what's coming in. Even if the fader is not turned up, you can see the audio coming in on that source if there is any. And if it's a source that gets a backfeed, so that would be any talent that has headphones, it would be any hybrid or codec, any source to which you're sending something back to it, that is metered on there as well. So you can tell, your operator can tell at a glance, am I sending a feed back to that person or not? That's just one of the benefits, one of the advantages that's designed into the Fusion console. Another thing is just simply the design. It is gorgeous, and it is so rugged and durable. There is no sheet metal on any of the surface that you're going to touch. The end panels are no longer molded plastic, which look fine on the Element, but now they're extruded metal and machined, and they are absolutely gorgeous. The entire top panel of the Fusion console, wherever there's a marking on the console, it's not a label, it's not paint, it's not a rub-on sticker. It is laser etched, and then it's double anodized. Now, I don't exactly know what that means, but I do know one thing about it. It won't come off, ever. It'll look as good 10 years from now as it looks the day that you install a Fusion console. Now, the Fusion console also, one change is that you now connect to the Fusion console with an Ethernet cable instead of with a CAN bus cable. It is changed to CAN bus inside the console, so those CAN bus runs are short, but now it's Ethernet, which means it's easier to locate that console wherever you want to, and not have to worry about being within a few feet of the power supply for the CAN bus to be there. Well, I'd like you to check out this console. It's got a ton of features that I haven't mentioned, lots of software features, lots of features in terms of how it handles backfeeds and mix minuses, and how it handles the auto record, the one button record feature. It's just amazing what it can do. If you've got a complicated morning show and then a not so complicated midday show and then a crazy afternoon show, the Fusion console can do all that stuff and make it look so easy for the operator, for the jock, for the talent, because so much is going on under the hood. And you, the engineer, you get to program it really just by easy check boxes, level setting. It's a pleasure to install and configure. I ask you to check it out on the Axia website. Well, go to telosalliance.com and look for Axia, and then look for the Fusion console. It's at the top of the list there. Of course, it's not a one-size-fits-all. You can buy a Fusion console with as few as, I think, about 6 or 8 faders, or you can get up to 40 faders split across 2 frames in a Fusion console. It's very flexible. You can have blank spaces. You can have telephone controls. You can have a large monitor module or a small monitor navigation module. Lots of there's intercom. You can have intercom modules built in, and you can have button panels built in. It's just amazing what you can do. There's something like, we figured this out one time, there are nearly 20,000 different configurations in which you can order a Fusion console. It's really customizable for you. On the Axia website, or on the Telos Alliance website, telosalliance.com, look for the Fusion console. And thanks very much to Axia for sponsoring this part of This Week in Radio Tech. All right, Chris Tobin is with us, and so is Alex. Let's give Alex the last word, and Chris, talk to us for just a minute, your philosophy on this curiosity, which you have a lot of yourself.
Well, I would have to say the curiosity is the best thing you could do in any industry, any business. So, but sticking to broadcast, one of the things that we all overlook is the ability to just look at something and say, okay, this is the agreed on, this is the perceived, this is what we do, this is how it always is. But what if you take that and do something else? Like, for instance, I recently was asked about doing a broadcast from a performance venue, a large performance venue, and the radio station was just down the block from the venue itself, the physical building. However, the drawback was they can't get ISDN installed in a timely fashion for the scheduled event. 2, it's just like there's no other way to get stuff in and out. That's not going to happen. So I suggested, and I thought this was kind of wild, and everyone else thought so too. What if you take an ubiquity dish antenna, take it outside the building, you can see the performance center down the block, use a speaker stand to mount the dish on it, point it toward the building, then go down to the performance center and find a place, maybe level, and point out back toward in the general direction of the radio station that can make a connection. Now, why I say general direction is because it's not exactly line of sight. The nice thing about these new 5.8 radios and the algorithms, they actually operate with non-line of sight. And as a result, you can still get connectivity, but not be point to point. And the nice thing is, if you go with a MIMO, like a 2x2 or 4x4, you can take advantage of the different antenna polarization. So you don't have 2 physical links for robustivity, so to speak, but you have one that constantly is working polarizations in order to keep the data rates going. And as Alex pointed out, drop down the data rate. Don't go with the the full 100 megabits. If you're only using 5 or 10 megabits for your link, because maybe doing video for the web, then do 10. This way you get the most robust link. It breaks every rule of thumb that most of these installations do. So that's the curiosity factor. I did this 5 years ago on the deck of a cruise liner in the Hudson River, and we did 5.8 from the deck of the cruise liner to the Empire State Building. There we took the output of the radio into our network LAN connection back to our studios in Lower Manhattan to do an 8-hour broadcast. And on that link, we did 2 radio station links. And I also extended our IP phone system out to the deck of the ship.
Of course. So why not? Why not have a phone on the deck of the ship?
I figured, what the heck? Let's give it a try and see what happens. And so if you can envision 2 different places on the deck of a cruise ship, one was a radio station doing all news reports from this July 4th broadcast that I mentioned was July 4th, and there's fireworks going on. And then our FM system music station at another portion of the deck doing their music broadcast and taking phone callers and talking to the studio, the producers. And they just pick up the phone and they would just call the extension, and people back at the radio station like, "Where are you?" Like, "I'm on the deck of the ship on the Hudson." What? It was a combination of a proof of concept. This was about 5 years ago. And everyone looked at me like, "Are you crazy? What happens if this happens?" I said, "Look, the ISDN made it to the dock. They can't get it onto the boat because the boat's fiber. They don't do copper."
Oh, no.
So I was working with the NBC TV crew because we did a co-broadcast with NBC TV, who does a July 4th Macy's event. So I worked it out with the technical director that they had brought copper up onto the deck for a couple of their remote cameras. So we piggybacked on a couple copper pairs, the ISDN as a backup failsafe, and because we did exceed the central office distance, so the bit error rate was a little edgy for the ISDN, but it was there if we needed it. And it worked. And ever since then, I've been just thinking out of the box, man. I just, what Alex is talking about with the Raspberry Pi, the 950 duplexer or diplexing an antenna system, totally breaks the mold and goes out of the realm. You need to think about it. And you know what? Remember this. Failure leads to success.
Yeah. Boy, Edison will tell you that. Good point. Alex, how about leaving us with some good words about your curiosity and how others should follow suit?
I think Chris just did. I really can't. I can't say much more than that, other than exactly that. I mean, I've always had this thing where people always said to me when I asked things like, what about this? And they always said, "Well, why would you ever want to do that?" I've always been the guy who says, "Sure, why not? Let's try it." Like Chris said. Failure, 99 failures for every one success. So you have to fail 99 times to find the one that works. And I've done exactly that. I mean, I, from a young age, remember, sticking the keys in the outlet and, that's how that works.
Oh, I did that too. Oh,
yeah. Everybody has that moment. And it's curiosity again. It's like, what does this do? And everybody who says, why would you ever want to do that? I never want to hear that again. It's like you don't want to say logical thinkers, programmers, for instance, are very, very difficult people to get outside of their comfort zone. You talk to a guy who programs software for like automation systems, for instance, and they ask him for a specific thing. Say, one perfect example is I have one of my PhDs is a sports-based station, so I do nested playlists, but the system itself picks the playlist. So it goes through and says, okay, I'm going to pick the year, 2010. Okay, what sport am I going to pick for 2010? I'm going to play football. Okay, what football game in that year are you going to play? Pick this one. Well, that makes sense, but to a programmer, they would always look at me and say, why on earth would you ever want to do that? You should be picking that and programming it yourself. And I'm like, because I want the computer to do it. That's its job.
Yes.
And so I did get a programmer to actually see it my way, and he's like, that's probably the number one selling feature of my software suite is that it can do it itself.
Yeah,
so saying why versus why not. Always say, why not?
Yeah. Or how can I do this? Yeah.
Exactly.
One thing,
and the internet will tell you. If there's anything that you can find on the internet, it's probably what you are asking.
something we didn't get to talk about because we're just out of time is that helicopter behind you. And so, Alex, I want to have you back on a future show where you can show us some of the things that you do with that helicopter. Quadcopters are the things nowadays, but not everybody can just go spend $1,000 or $2,000 or $8,000 on a quadcopter or an octocopter. You've got a monocopter there, and you've done some pretty cool things with it. So I want to hear about that. Will you come back and see us sometime?
Absolutely.
Great. It's been fun. Chris Tobin, if folks want to reach you and your Curiosity out of the box, available commercially for sale, they would email to you where?
Yeah. Support@ipcodex.com will do just fine. Support@ipcodex.com.
And you'll get supported. You will. If you send an email to that address and talk to Chris Tobin.
Hey, you mentioned that TV. You mentioned that doing the TV thing and that little remote that I talked about a long time ago. That was also one of those. Why would you do that? And it's your took us if things don't go the way they should, and they went very well.
Yeah. You are taking a risk.
Risk versus reward, my friends.
Yeah. Without the risk, there is no reward. Yeah, true.
Absolutely.
True. Hey, folks, Chris Tobin has been with us as usual, and also Alex Hartman has been our guest from St. Cloud? St. Cloud University of St. Cloud in Minnesota. So thanks a lot. This Week in Radio Tech has been brought to you by the folks at Lavo, at Omnia, and at Axia. Thanks very much to our sponsors. Suncast has been producing this show, and he's been doing a great job despite a couple of problems that I had with a camera and Alex had with internet, and so did Chris Tobin. So thanks very much, Suncast, for working through all those things. Thanks to the GFQ Network for distributing and also producing This Week in Radio Tech. Tell your friends about it, and be sure you get us on your podcast aggregator. In other words, subscribe. Subscribe to the audio and or the video. Get that happening automatically. You'll have it wherever you go. If you got, an extra 10 minutes on the subway, the bus, in the car, in the parking lot, waiting for your wife or kid or something like that, you can listen to a few minutes or watch a few minutes of our show and catch up a little bit. Thanks for your comments, and keep them always coming at thisweekinradiotech.com. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.